cold ischemic time. This refers to a period which a tissue, organ or specimen is kept at low temperature, usually on ice or in cold preservation solution after blood supply is cut off, but before either transplantation, fixation, or processing begins. Therefore, it preserves tissue morphology and molecular quality for accurate diagnosis and research. Examples of cooling methods or preservation solutions. Number 1, can use ice or simple hypothermia, whereby tissue or organ is placed in a sterile container, then surrounded by crushed ice or ice slush. This is common in short-term transport or pathology specimens before fixation. Number 2, cold preservation solutions, mostly used in organ transplantation. These are specialized solutions designed to protect cells, balance electrolytes, and reduce ischemic injury while the organ is stored cold between 0 to 4 degrees centigrade. Examples of such solution include histidine, tryptophan, ketoglutarate, mostly used for heart, liver, and kidney preservation. And for pathology specimens before fixation, specimens are kept on ice packs in a cooler box if transport to pathology lab is delayed. And for molecular studies, tissues can be snap frozen in liquid nitrogen or stored in RNA stabilization solutions. Examples of acceptable cold ischemic times. For a kidney, up to 24 to 36 hours, but best if less than 12 to 18 hours. The liver, up to 12 to 15 hours, but best less than 8 to 10 hours. The heart, only 4 to 6 hours because the heart is very sensitive to ischemia. Lungs, 6 to 8 hours. Pancreas, 12 to 15 hours. And for pathology, for example, breast cancer biomarker testing for estrogen receptor, progesterone receptor, human epidermal growth factor receptor 2, and Ki67, CIT should be less than 1 hour and ideally less than 30 minutes. Fixation in 10% neutral buffered formalin for 6 to 72 hours is highly recommended. And for general surgical specimens, must aim to minimize CIT, ideally less than 1 hour. Prolonged delays greater than 2 hours, for example, may compromise diagnostic quality and downstream molecular testing. So cold ischemic time or CIT is most applicable in two major areas. Number 1, organ and tissue transplantation, whereby transplanted organs are highly sensitive to ischemic injury. Ischemic injury refers to cellular and tissue damage that occurs when blood supply and therefore oxygen and nutrient is reduced or cut off. Keeping organs cold slows metabolism, which preserves organ viability. How does cold conditions slows metabolism? Number 1, cellular metabolism depends on enzymes, and enzyme activity is strongly influenced by temperature. So at normal body temperature, 37 degrees centigrade, enzymes work at their optimal speed. So cells use oxygen and ATP rapidly. So when an organ is cooled between 0 to 4 degrees centigrade on ice in preservation solution, enzyme activity drops drastically. Hence, chemical reaction inside cells slows down. Number 2, cooling slows the demand for oxygen by decreasing cellular respiration. This delays the onset of hypoxic injury because cells consume less oxygen. Number 3, ATP is consumed much more slowly at low temperature. This helps maintain ion pumps like sodium potassium ATPase and calcium pumps for longer, preventing rapid cell swelling and death. Number 4. At warmer temperatures, lack of oxygen forces cells into anaerobic metabolism, producing lactic acid and toxic metabolites faster. So cooling slows this build-up, delaying acidosis and injury. Number 5. Cooling stabilizes cell membranes and reduces the activity of proteases and lipases, the enzymes that can digest the cells by autolysis. So this helps preserve tissue structure.